Hey guys, just admiring this quadratic I get from tossing a baseball, that nice parabola. I suppose we can get started. Okay. So we have been working on graphing parabolas, graphing quadratics. We know how to handle intercept form. If it's factored, okay, we can easily spot those x-intercepts, can't we? Okay. And once we have those x-intercepts, where's that vertex? Boom, right halfway in between. We also know if it's in standard form, we can find the vertex pretty easily too. X equals negative b over 2a. We plot that point, we find an additional point, we reflect it over, and we're good. Okay. But now we're working on this vertex form. Okay. And in class the other day, we started to mess around with what that A does. And what I'd like to do is I'd like to pick up that investigation and continue to explore. We'll remind ourselves quickly how this A works and then how the H and the K work. So I'd like you to follow along here as I get on to Desmos. Okay. Now ideally you'd have Desmos open too, but here's the thing that I figured out. I realized that you can't watch a video on your Chromebook and be on Desmos on your Chromebook at the same time. So you'll just watch me here and let's have some fun. So let me put in our function f of x equals x squared. Okay, we know it looks like that. Then let's graph f of x equals a times x squared. Okay, and let's add that as a slider. And what did we see? Okay, we talked about in class as if a got bigger than 1, the graph got vertically stretched out. It was like I was grabbing the top of it and pulling it up. Okay. For example, if a is 2, what happens to all the y coordinates? Okay, 1, 1 becomes 1. Oh, I'm having a hard time getting there. 1, 2, right? There it is. 2, 4 becomes 2, 8. All the y values are multiplied by 2. Now, if a is between 0 and 1, that graph gets vertically squashed, right? It gets squished down. I use the word compressed. It's like we took the top of it and we put that pressure down. And that makes sense too because we're just multiplying y values. If my a is 0.3, I'm multiplying every y value by 0.3. Notice 1, 1 was on the graph. Now 1, comma, 0.3 is on the graph. We multiply the y values by 0.3, so it gets vertically squished. What happens if a gets negative? It gets reflected over. And it's possible for us to have both a reflection and a vertical stretch or a vertical compress happening to the same graph. Now, how about our h? So I have x squared. I know x minus h is in this vertex form. What happens as I change that value of h? Well, if h is 0, let's start with that one. If h is 0, x minus 0, that's just x. Notice it's the same as our parent function, as that base function before we do anything to it. Now what happens as I make h bigger and bigger and bigger? It's sliding to the right. Now be careful not to get confused. X minus h. Right now I have x minus 5.7. So when it's a minus 5.7, it actually moves it which direction? To the right. Okay? It's heading it this way. Now let's bring it back this way. Now h is negative, and it's moving the graph to the left. Okay? Right now it's minus 5. So what would that be? That's x minus h. So that would be x minus a negative 5. So in other words, this is x plus 5 squared, isn't it? and x plus 5 squared moves it 5 to the left. To the right, to the left, right, left, right, left. All right. Let's get rid of that. Now let's talk about the k. What do you think this is going to do to the graph? If k is positive, it moves it up. Why? We're simply just adding to the y values. We had f of x equals x squared. Now we have x squared plus k. So if 1, 1 was on the graph, now it's what? 1 squared plus, in this case, 3, which is 4. We're just adding this k, that in this case it's 3, now it's 4. We're adding that value to each of the y values, so it makes sense that the graph slides up. Okay? It's translating up. If k is negative, what's going to happen to it? It'd be like x squared minus 2 in this case. It slides the graph down. So plus k is up. If it's a minus, it's moving down. So let's put them all together here. Okay, and I've got sliders for all of them. Okay, so now let's do multiple things. Okay, let me put a back at 1. So it's just multiplied by 1, and let's put h and k at 0. We have our parent function. So now let's say I want to move it, I want it to be vertically stretched, moved right 1 up 2. Vertically stretched, let's make it twice as tall, and let's move it right 1 and up 2. Okay. What if I wanted to move it down 2? What if I want it reflected? What if I wanted to flip it over the x-axis? There we go. Okay. Now, we'll get into more of this more later, but what is the order of the transformations as we apply them? Okay. The first thing you do is stretch and reflect. Okay. The second thing you do is move it. Okay. You need to stretch or reflect. You need to work on A first, and then you can move it. Okay. As we do this, we can put that parabola wherever we want it. Now in class the other day, I told you this is my favorite way to graph a parabola. Okay? Not because it's always the most efficient. If it's in intercept form, it's going to be faster to use the x-intercepts. If it's in standard form, it's going to be faster to find the vertex using x equals negative b over 2a. But if it's in vertex form, this is the most efficient. But the cool thing is, okay, and I showed you guys this the other day, I shouldn't delete that, oh well, we'll start over, is it works for every type of function. Let me make up some other kind of function. What kind of function should I do? Let's look at functions down here. Miscellaneous functions. Let's look at, what should we do? What should we do? Decisions. You know, let's do a, no, let's not do that one. Okay, I think we did a trig one. Let's do another trig one. Let's do the tangent of x. Okay, that's what the graph of the tangent of x looks like. Okay, kind of crazy looking. If you didn't know it looks like that, it's really cool. I can't wait to study those with you guys later. But let's say we wanted to do transformations. What if I put an a in front, I put a minus h on the inside, and I put a plus k on the end? What is that a doing? Vertically stretching it. And if a is negative, what happens? It gets reflected over the x-axis. What does the h do? It's inside with the x. It moves it left and right. X's control left and right. If it's minus a number, minus 4.7, it moved right 4.7. Okay. If it's negative, it moves it to the left. What does the k do? Moves it up and down. We can see these same transformations. They work the same way for quadratics, trig functions, exponentials, logarithms, any kind of function that you're talking about. If it's in this form with an a in front, a minus h inside, and a plus k, the rules are always the same. All right. It's not hard to make some cool graphs. When you know how the rules work. And now I'm back to my parent. A is 1, there's no stretching, there's no reflecting. H is 0, you're not moving to the right. K is 0, you're not moving up. Okay, but if I make one of them change, there we go. So today I'm going to have you continue to play around with these. Okay, you're going to do what we call some marble slides. You should have some fun with that. I'm glad that we're getting understanding. In our next day together, we're going to really make sure that we have the vertex form down, that if I give you a quadratic in vertex form, you can very quickly find the vertex and graph it. With that, oh, here comes a joke. I am going to wave goodbye.